important that we remember that memorization and procedures do not equal understanding, particularly when we're talking about place value. In place value, it's not about naming the digit in the tens place. It's not about borrowing and carrying, and it's not about counting by ones or skip counting by tens. Not that that's a bad thing. It's just that none of these are evidence of sense making around place value. In other words, if a child can perform these actions, it is no guarantee of understanding. It's more of a testament to the fact that we have amazing brains that can memorize procedures and do them without any kind of understanding. So instead, we're going to focus on Standard for Mathematical Practice 7. We're going to look for and make use of structure. So in the activity today, we're going to build a context using a hundredths chart. And our purpose is going to be to build that place value understanding. So here's our humble hundredths chart. And the question that you should be asking yourself throughout the lesson is how does visual, tactile, and verbal representations, how do those support learning and support student understanding of place value? Or to put it another way, how can hundredths charts activities build understanding of the structure of our number system? So before we work with hundredths charts, we're going to back up a little bit and we're going to do a little bit of work with number lines. And you'll see why in a minute. But I just want to emphasize that a lot of our mathematics programs do not use number lines or hundredths charts. And this is really a shame because having a number of number line experiences is essential to children's conceptual understanding. So let me show you what I'm going to do with this hundredths chart here. I'm going to destroy it. I'm going to cut it apart by tens. And it's completely ruined now. And then I'm going to tape it together and I'm going to make a number line. And in a minute, I'm going to undo this process, and I would undo it right in front of a bunch of students in the classroom. Really, really important mathematical representations. In fact, if I could only have one visual representation in mathematics, I would choose number line. That would be the one I would use. This number line is, I'm going to call it a discrete number line. It's not exactly a number line because there are some attributes of number lines that it does not have. The main one is that it's really hard for me to put a point on this number line that represents 4 1/3, because instead of points on a number line, we have little squares representing the numbers on a number line. So I'm going to call it a discrete number line, but it still has a lot of the attributes that are important that will transfer to our hundredths chart. For example, the numbers are arranged in order, smaller to the left, larger to the right. You can use this number line to count on or count back for addition and subtraction, and also to compare sizes of number. The size of number here, this is one of the earliest introductions to the idea of number actually representing a measurement or a distance. It's a little bit different way of thinking about number. Instead of a quantity, a number of beans, a pile of beans or something, how many in that pile. This is distance as a quantity. And this number line, like other number lines, is intended to represent something that goes on forever in both directions. So to the left of that number 1, there's a 0. Can't see it, but it's there. And to the left of that 0 is a -1. And it goes on forever in that direction and goes on forever from the 100 to the other direction. So those are all really, really important big ideas about number lines. I wanted just to emphasize one other thing about number lines that is so important that is not going to show up so much in this lesson, but I think it's really valuable anyway. On this top number line, I would like you to put your finger on the point that you think would represent 5. So we have a 0 to 10. Where would the 5 be? And I imagine you put your finger right in the middle. Now below I have a number line that is 0 to 1,000. Where would the 5 go? Man, I think the 5 would go so close to that 0, I could hardly even tell. I probably made the point too big. All right. So number lines are a really great way of illustrating magnitude of number. So if I had a number line that went to 1,000,000, I would hardly even be able to tell that there was a 5 on it, right? So it depends on the scale. So scale and magnitude of number are really illustrated in number lines. I'm going to do something now, which might be painful for you to watch, but I'm going to take that lovely number line and destroy it. And I would do this right in front of students on my dock camera. Now that we've established some of the big ideas about number line, I'm going to build that hundreds chart, from the number line right in front. So I just created a stacked number line. What's great about this number line, which is called a hundreds chart, is that it really emphasizes tenness. And we're going to use these number lines in the classroom, just putting our finger on the numbers. So again, do notice that it's following a lot of those same rules. So just looking at that top row, numbers get smaller to the left, they get larger to the right. But now we have something else going on. By tens, numbers get larger going down and smaller going up. So when we're moving by units, we're moving left to right. When we're moving by tens, we're moving vertically up and down. So there's even a tactile connection to this idea of place value. Also, I want you to recognize that place value really is dependent. If we're going to talk about place value understanding, it's dependent on multiplicative thinking, because that's what those groups of tens are. So 10 ones and one group of tens can occur at the same time. So 10 hops of one or one hop of 10, you can hear that commutative property going on right there. They mean the same thing on this number line. So on this 100 chart, So let's practice just a little bit what I'm saying here. So if you could just put your finger on the number 23, just play along with me. Add 2, and you may have just jumped right to the 25 because you know 23 plus 2 is 25, but I would expect kids to hop to 24, then hop to 25. 1, 2, 2 hops and they're on 25. Okay, add 10, and you're on the 25, you probably jumped right down to the 35 because you've had experience with tens, right? And kids should have had experience with counting by tens and looking at the hundreds chart. And not just 10, 20, 30, 40, 50, but 5, 15, 25, 35, 45, from other numbers starting to count by tens. But many of them have not had that experience. So you will find a lot of children going 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Only what they're saying in their head is 1, 2, 3, 4, 5, counting by ones, up to 10 and landing on 35. That's okay. Kids have to be comfortable with something before they will expand their repertoire, let's just call it. So even if you point out to them that, look, I can just go from 25 to 35, you'll still find a lot of children still counting by ones. They'll get over it, because eventually I'm just going to make it so uncomfortable and tedious to do that they'll start just going, you're right, I'm just going to count by tens. I get it. But I'm going to let them do that in their time when they're comfortable doing it, when they really believe it so. So anyway, where were we? We were on 35. So I'm gonna pull a fast one on you, and I'm gonna say add 11. So again, a lot of students will count 1, 2, 3, 4, 5, 6, 7 until they get 11 and end up on 46. But we're gonna push kiddos that are ready and demonstrate for everybody and let them look at each other working on the hundreds chart to maybe add 10, 35 to 45, and then add 1 to 46. Or some children might add 1 to 36 and then add 10 to 46. Either way, 10 plus 1 or 1 plus 10, we know that we're allowed with addition to exchange the order of the numbers. That's our commutative property again. So yay. So, and children are also seeing 11 as 10 plus 1. One of the forms is 10 plus 1. Another one is 1 plus 1 plus 1 plus 1, 11 times. But this form, which emphasizes base 10, is 10 plus 1. So we're going to play a little game. I'm going to put a hundreds chart up in just a second for you to use. But these are the rules for the game, and I'm going to give you the rules that I use in a classroom, and then you can adapt depending on the technology that you're using if you're involved in distance learning, okay? So I'm going to give you several clues for what the beginning number is in this little treasure hunt type thing. And then when we get to the last number, if we've all followed the rules, we should all end up on the same ending number, and I'll give you clues for that also. I'm just going to ask you to follow along with your finger and use the 100 chart to do the work. You don't have to do this addition in your head. Use the chart and just touch and follow along. Listen carefully, because I cannot repeat clues. And this is really part of that classroom directions. But I'll tell you what happens when I'm doing work on the hundreds chart in the classroom. I'll say add 10, and one student will go, what? And then I'll tell that student add 10, and all of the students in the classroom add 10 at that point. So then we're all confused and messed up. So the rule is, I can't repeat clues, but guess what? You can whisper to your neighbor, what did she say? And your neighbor can tell you what the clue was. Or if you get lost, You can just look at somebody else's chart. That's the next rule. If you get lost, it's okay to look at a friend's chart to get back on track, because this is not a competition. I want everybody to get to the last number. Yay, the whole class. And if we don't, then we're just going to laugh about it and try again. It's not that big a deal. And then, of course, for you, you can rewind. So that's easy. Just rewind if you get lost. Okay, so here's a chart, and here's the clues. And I'll try to go through this a little bit faster because you can always go back. Okay, we're going to begin on the number of cookies in a baker's dozen. It's also the number of cards in each suit of a standard deck of cards. If you have a fear of this number, you suffer from triskaidekaphobia. It's also the number of stripes on the American flag. So on the count of 3, I'm going to ask everyone to say it out loud. And if you were doing this remotely, I'd say unmute. And on the count of 3, say what number we're going to start on. 1, 2, 3, 13. Yay, everybody's on 13. Okay, here are the directions. Add 2. Plus 10. Increase by 30. Decrease by 3. Add 11. Plus 22. Take away 9. Minus 50. Plus 9. Subtract 2. Okay, now you could pause and you could go back. So I'm hoping that wasn't too fast for you, but I do bet that that take away 9 or that plus 9 were kind of head scratchers for you, right? Those are the most difficult ones in this whole little game. Anywho, let's see if you ended up where you belong. Okay, are you on a palindrome? What's a palindrome? It's a number that reads the same forwards as backwards. It's also, this number that you should be on is also the number of sides on 11 triangles. On the count of 3, let's say the number out loud. Ready? 1, 2, 3. 33, I hope. Okay, so let's review some of the directions and their purpose, the intent of creating this little talk, which, by the way, is really easy to create as long as you're purposeful. So to begin with, a whole lot of vocabulary and clues were in the directions, right? So beginning on 13 and all the clues for 13, the adding the 2, the plus 10, see all the synonyms that I'm using for the operations here. Increase by 30. Why do you think I went from a plus 10 to an increase by 30? And by the way, all of these different I'll say extensions of the basic operations that are going on in here, they wouldn't happen in one game, right? You might introduce just adding units and tens, or subtracting with units, adding and subtracting in units, then adding and subtracting with units and with tens, then going to something like 30. But we did that, why? So that we could discourage the counting by ones, because it's so much easier just to move down 3 rows for 30. Okay, decrease by 3, a little more vocabulary. Add 11, we talked about adding 11 before. Adding 11 or subtracting 11, what does that look like on here? Takes a little practice, but it's great because we're thinking in tens and units. When we get to numbers greater than 10 that we're adding and subtracting, we have to think of the tens place and the units place. So that's reinforcing. And remember, with the movement, horizontal for units, vertical for tens, which is also reinforcing that place value. 10 is not a 1 with a 0 stuck on it. 10 has its own meaning. 20 is not a 2 with a 0, or it's not a 2 in the tens place. It's a vertical movement of 2 rows, each row having 10 in it. Okay, add 22. Sorry, I'm getting on my soapbox. Subtract 9. I bet that was a doozy for you right there. Most children will count back 9. And I bet many of you did too, except I was going so fast. But eventually we'll come to a place where we subtract 10 and then think about it, wait, 10 is more than I wanted to go back. So I have to compensate with 1. Take away 50 and then plus 9. The adding the 9 tends to be much easier than subtracting 9, right? And then minus 2. So you get the purpose for all of the different moves that are on here, right? And we're just really playing with the structure of not only place value, but of number lines and hundreds charts, right? So I have a question for you and a comment here. So the question is going to be, do the rules still apply? Is the structure consistent? And it better be if it's math. But what happens when we move to a different place on that hundreds chart or on that number line? So now I have a hundreds chart, but it begins at -49 and goes to +50. And part of the reason why I wanted to bring this up is not that you would do this with second graders, although you might be able to. But we have a lot of kids in upper elementary and even middle school who haven't had experiences on number lines or really don't understand base 10. I think we have a lot of adults that really don't understand base 10. So sometimes a little time spent working with number lines and with hundreds charts to bring those kids, to give those kids some of the experiences that other kids have had. They've just lacked the experience. So we can do it in a grade level appropriate way by maybe using a 100 chart that has negative numbers on it. So, I mean, just an idea, right? And then we can modify the instructions. So, for example, we ended on 33 last time. So maybe the hints I give are going to be a little bit different. About the number of, are you on the number of innings in the longest professional ball game in history? 33. Who knew that? Well, Wikipedia did. Okay. Is the product of the digits that you're on 9? Is the sum of the digits 6? Is the quotient of the digits 1? Is the difference of the digits 0? We can really up the ante on the language and the type of questions that we're asking and still give kids experiences that will help solidify their understanding of place value. Okay. Oh, so here's some other examples. Begin on the only single digit perfect cube number. Add a -11. Whew. Right? Subtract +3. We can make it grade level appropriate and still be building that understanding. Okay? And we can ask questions about the consistency of the structure. If +49 equals the positive quantity of 40 plus 9, does -49 equal the negative quantity 40 minus 9? Ponder it and then explain your thinking. Give me an argument. Next time, we're going to again use the hundreds chart to talk about the structure of our number system. But this time, we're going to generalize these rules of number to algebra. And yes, kids can do it. And guess what? You can too. See you next time.